It's a great pleasure to be here. It's always nice to have a public forum to sort of work through one's obsessions. And I do have to admit, I've been working on these for the last 2.5 years, and they really have become something of an obsession. And I hope I can convince you tonight that they're about half as interesting as I think they are. Some of the work I'm going to report on has already been published. Some of it's in press, and some of it's still under review. We're in the process of putting together a special issue of the Journal of Human Evolution that deals with the geology, the archaeology, and the paleontology of these fossils. So please stay tuned. I also just would note that most of you may realize that my title is a nod to Stephen Gould and his Hobbits, his Dinosaurs in the Haystack. And one of the take-home points tonight is that fossils don't reveal themselves to you. You have to work very hard. You have to look in places that might even be unexpected. You have to take the haystack apart in order to find fossils, including hobbits. Just to give you a quick overview of where I hope to go today, I'm just going to give us a bit of background. I don't know the background of everyone in here, so I'm going to assume very little. Sort of mention what the response to the announcements and early descriptions of this material was, both in the public domain and in the scientific world. I'd like to outline what have emerged as sort of very strongly contrasting and competing hypotheses for how to interpret these fossils. And then I'm going to turn to things that I really have more expertise, and that is the skeletal remains themselves. I'll mention something about the skull, mandibles, and the brain, and then I'll focus on the postcranial skeletons, that most wonderful part of the body. And finally, I'll try to wrap this up a little bit with some implications, at least the implications I see, and a few concluding remarks. I'm going to try to cover a lot of ground tonight, so I'm going to move quickly. I'm going to talk more about results and my interpretations of those results. But in the question and answer period, I'll be happy to go into methods as much as any of you could stand. So don't hesitate to ask about how I arrived at certain conclusions. Like any major paleontological project, this is very much a team effort. No one does modern paleontology, human paleoanthropology, except as a team. Clark Howell was the person who probably pioneered this approach. Interdisciplinary paleoanthropology is certainly one of his many legacies. The people you see here have been part of the team that I've been working with. This is Tony Jubiantono. He's the director of the Archaeological Institute in Jakarta, where this material is housed. This is Mike Morwood, who is the team leader and the archaeologist whose vision it was to go back to this cave site and dig deeper, and we'll talk about that. This is a colleague, Thomas Futikna, who is a CT expert and who's been particularly helpful in gathering those sorts of data with me. This is my colleague, Susan Larson. This woman, Lorraine Cornish, it turns out to be a very important person because she is a preparator from the Natural History Museum and Paleontology Department in London. These fossils are incredibly fragile, and it was Lorraine's task to come in and repair them after a kind of, shall we say, eventful trip out of town. And she helped them put them back together, repaired them, and has hardened them so they'll be able to be studied by future generations. The lab situation is interesting. The fossils are kept in an air-conditioned room. The people who work are in a sauna, and it's the most unbelievable working situation I've ever been in. Finally, Matt Tucheri joined the team very recently. Matt's a postdoc at the Smithsonian, and he's the one who's brought laser scanning and digital capture of information to our project. And Matt and I were back there in November of 2007. Well, I'm at the age now where I get to reminisce a little bit. So I just wanted to tell you what sort of the perspective I brought to this was when I was in graduate school in the University of Michigan a few years ago, in the early 70s, things seemed so simple in terms of interpreting human evolution, especially if you were studying under Milford Wolhoff and C. Loring Braith, where things were sort of seen in a very unilineal, almost stage-like progression, where you went from this thing that was not widely accepted, but an ape of some kind, let's call it Ramapithecus, through Australopithecus, maybe Paranthropus, if Milford lets you say that word, Homo erectus, and then to archaic Homo sapiens, which certainly was Cro-Magnon, but in some cases even included Neanderthals, then to modern people. This was very simple, very elegant, and it seemed to fit some of the data pretty well. We'll have to say what a change 3 decades has made. This is sort of the latest version from the Smithsonian, and the point here is that human paleontologists, have been taking the haystack apart all over the world. They've been looking and they've been finding. They've been finding things in places and in times we never imagined before. Fossils, fossil hominids in Chad. Who would have imagined such a thing? Homo erectus in Georgia. And then the list goes on. What is revealed now in terms of human evolution is hardly a straight line. It's a bushy tree, and you sort of connect the dots at your own peril. I don't think we have a full understanding of who is ancestral. And these sort of evolutionary trees are of heuristic value, but they're probably not telling us the full story of human evolution. A couple of other things I'd want to point out is that, that in many time horizons, there is more than one taxon apparently alive, not necessarily living in the same place. There are multiple species at any one time. Also, I would point out that this chart of human evolution is very, very centered on Africa. There's very few fossils, Homo erectus, and a few others that can be attributed to fossils from Asia. I would argue that Asia is still full of surprises, and I think it's going to be revealing a lot of them in the near future, and I can talk about some of that, some of the work that Mike Morwood's doing in other places afterwards, if you like. I'd like to suggest that, and this is an oversimplification, but it's close, that there are basically 2 fundamentally different body designs in human evolution. And both of them are quite successful. But the one you see is exemplified by Australopithecus afarensis, Lucy, is perhaps the most successful one. It's the one that I see emerging in Auroran and persisting throughout Australopithecus, maybe into Homo habilis. It lasts probably for 4 million years. I believe it involves a combination of good bipedalism and arboreality. We have very, very short hind limbs. We have flaring pelvis, small hip joints. We have small brains, large teeth. This is one major design. Roughly around 2 million years ago, we see a major reorganization. Perhaps it was earlier, but the first evidence is just after 2 million, where we see this long linear physique. We start to see modern human body proportions with long femora and long legs and shorter upper extremities. The pelvis has changed in its shape. There's been brain expansion, etc. It, in many ways, is already very similar to what we recognize as ourself. Now, there are some differences to be sure, and I'll talk about one in particular on the shoulder in passing today. Then there's this thing here. This thing called Homo habilis, or if you're Bernard Wood, you might call it Australopithecus habilis, where its body design is not well known because this is one of the most complete individuals. It appears in many ways to resemble Australopithecus postcranially, but there already appears to be some brain size expansion. It appears to be a tool user. And for me, this is turning out to be really a very, very interesting fossil that I think is relevant to the evolution of floresiensis. Okay, now, when this paper first appeared in October of 2004, like many of my colleagues, I think I had to check the date to make sure this wasn't some kind of early April 1st cover, because it just seemed incomprehensible that there would be something so tiny and it was just lost in time and space. It didn't make any sense. It was coming from a period about 12,000 to 95,000 years ago in Southeast Asia. We know people don't even get to Southeast Asia, modern people, till almost 50,000 years ago, and they're first seen in Borneo. So that date, 95,000 years, means a lot. We also know that this area is incredibly isolated. It's part of a group that's called Wallacea, and even in the lowest sea levels, even the last maximum glacial, these islands are not connected to this part, to Sundaland. So these are isolated. Now, Flores had been in the news before then, because Flores earlier had been reported to showing in the Sua Basin artifacts dated to 800,000 years ago. Now, this created a debate in its own right. There were no fossils, just artifacts, but it suggested that Homo erectus, that was the guess at that time at least, somehow got to this isolated island 800,000 years ago. And there were public papers about swimming and rafting and boats in Homo erectus. We don't know how it got there, but it got there. So I was very much a fence sitter when I first got involved in this project too. I wasn't sure what this was. I was having a hard time reconciling it with sort of how I viewed the evolution of humanity until this point in time. This is the cave where it comes from. These are the two seminal papers, both published in Nature, announcing and describing the fossils. Work is going on. They're returning, and I'll get to join them this summer in July and August to continue the excavations. The politics seem to have sorted themselves out. All right, I apologize for this slide's very washed out, but this was also taken from Nature, and there's sort of a phylogenetic tree here. Now, the first response was the ancestor of floresiensis must be Homo erectus. And the argument was essentially a biogeographical argument. There were no other fossil hominins known in that part of the world. There were fossils known in Java of Homo erectus. Therefore, this must have come from Homo erectus. If these fossils are derived from Homo erectus, that means there was some severe dwarfing event. Homo erectus is a big hominin compared to these guys. Well, subsequent to that, and the dotted line indicates my sort of question mark in this, the two cladistic analyses, the two phylogenetic analyses that I've seen to date so far, based on skulls and teeth and jaws, suggest that Homo habilis is the sister group, is the closest relative to floresiensis, not Homo erectus. Now, what's interesting about that is it would require an out-of-Africa event that we haven't ever seen before, thought about before, obviously. But nicely, it would not require any size reduction at all. We wouldn't have to posit these guys as dwarfs of any kind. The more I studied the postcranial skeleton, the more amazed I became by how similar it was to Australopithecus. Now, I'm not suggesting it's derived from Australopithecus, but if it were, again, you wouldn't need significant size reduction. But I'll show you today that it is remarkably similar postcranially to Australopithecus. All right, let's take a look at the cave again. This is the King Liangbua. It's a cave that's been well known before to archaeologists. Archaeologists have worked here Verhoeven was there early on. But what happened was the archaeologists in the past had dug down to about 10,000 years, 12,000 years, recovered Neolithic burials, artifacts, and found this volcanic ash at 12,000 years and stopped. Packed their bags and went home. Well, Mike Morwood had a clever idea. He said, let's dig deeper. And what he did is he got some advice, believe it or not, from grave diggers, as how to shore up these sides. And he dug down 6 meters. And on the way down, he found extinct animals, artifacts, and occasionally fossil hominins that didn't look like people. What he found at one level, and these are all from this sector right here, sector 7 and 11. There's a little bit of an overhang here. What he found was what is arguably one of the most completely and best associated fossil skeletons ever discovered, crania and postcrania. And I'll show you some pictures of that in a minute. And it's this individual that became the type specimen of Homo floresiensis. All right, so here's what the skull looks like if you haven't seen it before. It's fairly archaic in appearance. I'll go into more detail in a moment. There is a little bit of damage due to excavation. These bones were found there in sort of a water, soggy environment, and they were described as sort of like wet paper mache, so they had to be hardened in situ. So there was some damage, but you can see some things here. There's no chin, and we'll go over some of the details. But this was sort of what was presented as a virtually complete skull and mandible. Now, this really captured the imagination of both the scientific and the artistic community. And here are some of the, what I call the many phases of flow here. The number of reconstructions are really staggering, and some are quite stunning. This one seems to be surprised by all the hubbub. These seem to be a little wistful, if not mournful. This was from a site called Flores Girl. Check it out. It's pretty amazing. But these sort of see, yeah, we're going extinct. They looks pretty. But these over here in particular, they strike me as they're angry. And I wasn't sure for a while, but I've been working on this material for so long now that I've started to channel hobbits. And you probably think I channeled several of them if you look at me. But I think I now understand why they're angry. All right? And I'm going to point out today that this is a pretty unlikely scenario, but I'm getting ahead of myself. This is what goes with that skull. The rest of the type specimen is truly astonishing in its completeness. We have pelvis, we have upper limb bones, we have lower limb bones, patellae, we have hand bones for the first time, and we have almost complete feet. And I've really become obsessed with feet of late. This is just for the American Museum to sort of give you a schematic of what we know. And the reason there's more bones over here than here is we continue to find bits and pieces in bags that were collected. We continue to sort the material. It's just been a ton of material excavated. But I also want to indicate that we're not talking about one hobbit, not one individual Homo floresiensis. Depending on how you divide it up, there could be as many as 12 individuals, but some of them are very isolated teeth. One's an infant, and this is sort of based on age in addition to sort of criteria of number of individuals of particular bone. But one in particular, LB6, is quite interesting. It has a mandible that's very much like LB1's. It has a scapula that is remarkably human-like. And in this respect, I would argue that it's the shoulder blade that is one of the things that is most Homo-like of Homo floresiensis. This is the ulna and the radius. So we have a forearm. And I don't know if there are any medical folks in the audience, but I showed this to an orthopedic surgeon. He said he thought it might be the earliest example of a Colles fracture. The paleopathologists at the Smithsonian do agree it's a fracture, but they think that's too proximal. So yes, there's pathologies, but this is a healed fracture, and this bone seemed to function for a long time after it healed. These are the paired tibia of LB1, type specimen. But why I show this little tibia here is this is LB8. It turns out that LB1 is the big girl at Flores. It's the largest individual in the sample. And its pelvis indicates it is, in fact, a female. So I don't know if we're having some kind of sampling bias, but either that or we have a reverse sexual dimorphism or something crazy going on that I can't imagine. But there are other individuals, adult individuals in Flores that are even smaller than LB1. All right, so there was also a lot of fun in terms of trying to flesh out the entire body. You saw the artistic attempts to do the same for the crania. Here's the artistic renditions of the full body. This one's a bit of a problem. This could use a little Photoshop. This is a male representation of LB1. And we're pretty sure that LB1 is a female. This is a recent reconstruction done on display at the Muséum de l'Homme in France. I rather like it. I think the shoulders are a bit broad, but it gives you that sort of short and stocky appearance. And in fact, it shows you that the upper arms are quite long relative to the legs. And I'll point out to you later today, that's really because the legs are incredibly short for the body size of these individuals. And then there's those crazy Dutchmen over here. And this was the only time I've seen this reconstructed as a quadruped. And I think that's because the upper limb is long relative to the hind limb, and this individual thought, gosh, that must mean they were on all fours. So I would say that we can write that one off, and in fact, this hobbit is probably more similar to the actual Homo floresiensis than this one. And in particular, I want you to pay attention to the large feet and the very short hind limbs. This will become important down the road. All right, the response to this was pretty amazing. There was, the public was interested in it, as they often are in fossils, especially special new fossils. And there were a lot of pundits, as Desmond Morris was quoted, that this was somehow different. The Indonesian island of Flores is rather different. In theory, the existence of mini-man should destroy religion. but I can already hear the fanatics claiming that he has been put forth on earth by the devil simply to test our faith. Well, Desmond, that's going out pretty far. It's certainly the case that I'm sure that creationists are interested in this, but the last time I checked, religion was alive, if not particularly well. And if you go onto the websites of some of these creation websites, there is a lot of discussion about floresiensis and special creation and things like that that you can imagine. I mean, that's sort of expected. But it was the scientific response that in some ways is more interesting. And I experienced this momentarily too. I understand it, that when you're confronted with things that don't fit your preconceptions, it's not uncommon to sort of dismiss them out of hand or make up things to take care of that problem. As Henry G. said, such reaction is common in the wake of new hominid discoveries, which are routinely dismissed as pathological humans, Neanderthals repeatedly, or apes, like Sahelanthropus, huh, Dan? It happens. Such reactions say less about the facts than the mindsets of commentators who might be unwilling to have their comfortable views of the world so forcibly changed. Can I get an amen? That is absolutely true. You're confronted with a new set of facts, and denial is the first resort. What I'm going to try to convince you tonight is that there's an alternative interpretation, and it's going to require us to rethink many aspects of human evolution. So what it's boiled down to now is sort of two competing hypotheses, as Dan alluded to, and they have become controversial and contentious. The camp, I guess, that I'm involved in terms of describing this, views these fossils as a new species, although Peter Brown's backing off. He wants to name a new genus called Sundopithecus. There's a small-bodied Homo with a mosaic of primitive and derived features. The primitive features are really manifest in the postcranial skeleton, a few in the craniofacial region, and the derived features are manifest in the brain and in the dentition and some aspects of the face. The alternative point of view is kind of a grab bag, what I would call sort of the mutant microcephalic dwarf or the pathology du jour group. It's really pretty interesting. No matter, you confront one and you cut its head off, it's like the Hydra. The two more sprout up. It's unbelievable. Then two in 2008 already. The three that sort of have emerged in very respectable scientific journals. One is Laron syndrome, which is a type of pituitary dwarfism. One is a kind of osteodysplastic primordial dwarfism. There's a recent paper in Science talking about this, and there's a very recent paper that just came out claiming that the hobbits suffered from hypothyroidism and were cretins. I really don't want to spend the rest of my chat sort of doing a point-by-point rebuttal. As my colleagues from Stony Brook will attest, I'm capable of turning this into a rant, and I really don't want to. I want to present some evidence along the way, and sometimes give you a few counter examples of why I think this is misguided. But you can read the papers, you can look at the fossils, you can make up your own minds. All right, let's go back to the skull again. It's really a magnificent thing, and it has a very, like I said, a very archaic gestalt. It has a sloping but not a flat forehead. The face is prognathic but relatively small. Yes, it lacks a chin. Chin expression is highly variable in the fossil record, and even among people, perhaps even among people in this room. The mandible is incredibly robust. The cranial bones are very, very thick, and here's the kicker. It's got a small cranial capacity, about 417 cc's on the latest digital estimate. That's in the chimpanzee range. Only the smallest Australopithecines have a cranial capacity this small. That's a small brain by any standard. It also has lots of air in the bones. The bones are highly pneumatized. And in this region in particular, that's very characteristic of African apes and Australopithecines. This degree of air holes in the bones themselves is quite a primitive feature. And I would argue that most of these features are in fact primitive compared to modern humans. And there are no modern human pathologies that reproduce this suite of features of the skull. Now, the first attempts to sort of say, what does this thing look like, First quantitative attempts was published in the Journal of Human Evolution in 2006 by Debbie Argue and colleagues. They took a suite of measurements on the skull, they size adjusted them, and they said, what does it look like? Well, it looked unique. It really wasn't like anything specific. But what they said was, if you were forced, if you sort of twisted my arm and made me say, what is it most like? It turned out to be more like this African Homo ergaster, or early erectus, if you like. That was their best guess. They didn't say it was just like it, but they said it was most similar to it. And it is true that there aren't many crania with faces in Southeast Asia. This is from Java. This is the most complete. This is Sanjiran 17. And it really doesn't look a heck of a lot like LB1. That's certainly the case. But this doesn't look all that much like it to my way of thinking as well. I'll show you another suggestion as to what it might look like in just a moment. So, but phonetically, in terms of overall similarity, it seemed to have sort of an African flavor, maybe an early erectus, or maybe an early habilis. Because again, as I mentioned earlier, the cladistic analyses done to date are suggesting a close connection to Homo habilis as opposed to Homo erectus. Now here's another approach, and I'm not going to dwell too much on the methodology, I just want you to get a feel for it. I have a postdoc in my lab named Karen Babb, and she had done this work before she joined my lab. I think the work is just fascinating. What she's done instead of, she's put the calipers away and gone around the world with a 3D digitizer to collect XYZ coordinates, and you can see some of the points that she's measured here. And then what you can do with that, you can try to superimpose these points to get to a maximum fit and sort of see where the points don't fit. And you can calculate measures of shape. You can eliminate size, you can look at shape. And what you see in this plot really should be regarded as sort of, this is a cranial size axis, this is a shape axis. These are the principal components of shape, the form in this case. These are African apes, gorilla males, gorilla females, chimpanzees, and pygmy chimpanzees. They sort of form an allometric gradient. Right? They change shape predictably with changes in cranial size. These are humans, all the X's. It's noisier, but you sort of see a similar pattern, but it's displaced because the shape is different. Here we can see Australopithecus and Paranthropus. Not many points, but sort of a parallel. What we see in the dotted red line here is what you get if you take Homo erectus and Homo habilis and you project it down and predict what would a fossil the size of LB1 look like at this cranial size. And here's where LB1 is. It's remarkably close to that prediction. So in many respects, I think it's fair to say that it's reasonable to view LB1 as a very small, allometrically scaled down version of early Homo, Homo erectus and Homo habilis. At least that's our best guess to date. There just aren't many skulls that have both cranium and face preserved. All right, let's look at the jaws quickly. It's a very primitive jaw. Here we see on the left, this is Australopithecus. This is part of the same group as Lucy afarensis. This is the second jaw. This is LB6. This is a robust jaw. This is an incredibly robust jaw. LB1 has big teeth, but they're not any near as megadont as you see in Australopithecus. So they're clearly derived, really more modern in aspect than Australopithecus afarensis. No doubt about it. So it's fair to say they're only slightly megadont. And small-bodied pygmy people around the world are also slightly megadont, because undergoing body size reduction affects the skeleton much more so than the teeth. The teeth stay large, relatively large. But I want you to look at this CAT scan down here, because this is where it gets interesting. And I think the chin issue, they don't have a chin. It's a red herring. Yes, they don't have a chin. But look at this scan right here. This is through the middle part of the jaw. See these little bumps here towards the back? You can see them here as well. Here's an outline of those. So this is the front of the jaw, front of the jaw, front of the jaw, and the two hobbits, and Australopithecus. And this is the tongue side of that jaw. These little bumps are called superior and inferior transverse tori. They're little buttresses of bone that resists bending and shearing in mastication and chewing. This is a modern human down here. You never see superior and inferior transverse tori in any human, pathological or not. This is an incredibly primitive aspect of the jaw of Homo floresiensis. This is not a little person. This is something very, very different. And I think you can start to see how thick the cranial bone is as well. All right, the brain. A lot of controversy. This is where the microcephalic argument sort of kicks in. Dean Falk first published a paper in Science where she argued that, yes, the brain is small. The brain size to body size ratio is more like an Australopithecus than anything else. And this little thing down here is to show you. For a given body height, there's floresiensis. I mean, it's really down there. If this were body mass, it'd be into the envelope, but it's small. No one argues that. But what she pointed out is that there are other aspects to this brain we need to look at other than just size. That is, if you look at sort of the convolutions on the endocast of this brain, she felt in the frontal region and in the temporal region, she could see derived features, enlarged gyri, that she believed were consistent with what she called capabilities for higher cognitive processing. Many of these were in the frontal lobes. They were in the area, Brodmann's 10 area in the frontal lobes, which is involved in multitasking, in planning, things like that. The other parts of the frontal lobe that seem to be enlarged that are related to appropriate social behavior. Now, you know, this is a stretch, I realize, I mean, from bumps on endocast. But in those were the respects in which they appeared to be very, very human-like. And so her point was, yes, it's small, but it's derived in terms of how it's organized, that there's more to brain function than cranial capacity. We need to look at how it's put together. Now, the critics have said that, well, there's just no way you can scale down a Homo erectus and get a brain this size. Just not possible. Well, we don't know it came from Homo erectus. We didn't know there were 600 cc cranial capacities in Dissonance, early Homo erectus in Europe. And when did mammalian brain scaling ever explain anything in human evolution? It doesn't explain our enlarged brains. If it doesn't explain it on the way up, why should it explain it on the way down? I don't understand. I don't think this is a really valid criticism, that it doesn't fit the trajectory of dwarfing in elephant brains. Okay, I'll give you that. But it's small and reorganized. But the detractor said, that's still a microcephalic. And so I think Dean finally put this to rest, I would like to think. Last year in PNAS, she did a discriminant analysis. This is an analysis that sorts things for you. She took a bunch of human brains, a bunch of microcephalic brains. She did a discriminant analysis and could sort them completely based on linear measurements on these. Then she said, let's take another microcephalic and see what happens. Boom, it's put in the microcephalic pile. Let's take a dwarf. Boom, it gets put in the microcephalic. Let's put LB1. It groups with modern humans. Now, it groups with modern humans because it looks more like a modern human than these guys. But in reality, it looks like the endocast of Homo erectus. It tends to be very flat, for example. It has very large temporal lobes. But what it doesn't look like is a microcephalic. And this has not been responded to yet. All right, so how small are the hobbits? All right, now these are some attempts. This is Nat Geo attempt. This was Scientific American. Again, this is the lady who created this model in France. Again, I'm not going to go into the methods on this for you, but I'll be happy to discuss it. These are my estimates for it. I estimate these guys to be roughly 100, just over a meter tall, 105 to 108 centimeters for LB1. For those of you who are metrically challenged, that's about 3 foot 5 inches to 3 foot 7 inches. That is short. All right, the smallest people on Earth are about 4 foot 6. Those are the smallest pygmies, and I'll show you a slide of that in just a second. So these are incredibly short. And remember, I keep talking about these short hind limbs? That's why. In terms of body mass, 30 to 35 kilos, 66 to 77 pounds, is not large, but there are plenty of very small-bodied humans in these pygmy populations around the world, females in particular, that do get into that size range. So they're short and stocky is the take-home message. But again, I'd be happy to talk about the methods if you're interested. And just to put this, I apologize for this. It looks great here. This got really blown out. This is a world map, but the dots are actually important things. It shows you the distribution of pygmy people around the world. And you can see most of them occur in the tropics. A lot of them occur on islands, but not completely. This was in a recent paper, a magnificent paper, Migliano and PNAS, trying to account for what is it about these people? What do they have in common? Why do we see human dwarfing again and again and again? And they came up with a very novel idea. And it had to do with you need to reproduce early. So you stop growing early in the face of high infant mortality and high adult mortality. They argue that small stature is simply a secondary effect of this life history problem, and that it's occurred again and again in modern humans. Here's the range. 140 to 144 is still about 4'6". So there are no people in the world that get as small as the hobbits, and there are no people in the world that converge in terms of their skulls, brains, or postcranial skeleton on Homo floresiensis. Homo floresiensis is not about body size only. It's a very different body design. Let me just give you one quick example of that. And this is just a graph to show you how you pack body mass onto your skeleton. It's a simple little index where you take body mass and you divide it by how tall you are. And this data is actually courtesy of Richard Wrangham and Milford Walpoff from a while back. These are what African pygmies look like. There's a range of variation in how much mass they put on their skeletons. Here are hobbits out here. Hobbits are like Australopithecus, they're like chimpanzees in the amount of body mass they're carrying for their height. So there's another perhaps primitive feature that recalls Australopithecus. Again, I don't want to put you into a coma with graphs and data, but I do want to point out that there's some data behind some of these things that I'm saying. I keep saying that the hind limb is short. It's not the upper limb that's long. This is a simple index, just the ratio of humerus to your femur. And these are among the smallest people on Earth, African pygmies and Andaman Islanders. Here is LB1, here is Lucy. There are no small-bodied people that ever have a humeral-femoral index in the 85 to 86 range, period. And the reason they don't have it is the relative femur length. This is relative to pelvic height, could be any other size variable. Here are pygmies and Andaman Islanders. Like you and me, they have long hind limbs. Here's LB1 and Lucy. So they have absolutely and relatively short hind limbs, and that's what makes their stature so short. That's what makes their body proportions so Australopithecus-like. Now, let me just run through a couple of other bits of the skeleton and let you ask me some questions. If you can give me another 15 minutes, I think I could get through this. I'll skip some of the ad hominem stuff at the back. One of the things that is interesting about the shoulder of hobbits is that it is remarkably similar to Homo ergaster in Africa and to the Dissonance humeri. And I think Phil Reitmeyer is here, who's been working on that material. He can vouch for this. It's funny, the humeral head faces backwards in all of these, including the hobbits. Now, if your scapula, if your shoulder blade's on the back of your body, that means your arms move in this plane. Now, that's great. The national meetings I go to where there's a lot of arm waving. But I got to tell you, if you want to put your hand, if you want to manipulate things in front of you, that's not a good position. This requires your scapula to be repositioned on the side of your thorax. LB1 has a short clavicle to facilitate this. And Susan Larson and I have argued that we think this is a primitive condition for early Homo that's been retained in Homo floresiensis. That this backwards facing humerus Just one more little example of something that's quite different. This changes later in human evolution, and what you see in knuckle-walking apes is completely convergent. All right, now, this is a complex story, but I love it. There's these wrist bones. Wrist bones are very hard to sort and to study. Matt Trocheri, through laser scanning, has been able to capture the morphology of the Hobbit wrist bones. And we published a little paper in Science last year where we sort of revealed what was shocking to us. That if you look at these bones, whether this is something called a trapezoid, a scaphoid, and a capitate, and the trapezoid is really pivotal in this story. In apes and in Australopithecus, this is a little wedge-shaped bone. In modern people, it's shaped like a boot, and it has to do with sort of the thumb becoming a powerful manipulatory organ later in human evolution. Now, you don't have to do any fancy stats, I think, to see that the Hobbit looks like a chimpanzee, bone by bone. It doesn't look like a person. And when we have fossil Australopithecus to compare it, they're over here as well. And if you don't believe your eyes, here's a multivariate analysis. Here is apes, here are humans, there's floresiensis with the apes, this is the trapezoid. These little marks are interesting here. This is a pituitary giant and a pituitary dwarf. Pathology, you don't wake up one day and go to the doctor and complain of having a chimpanzee hand. All right? If you're a pituitary dwarf, you still have the morphology of a modern person. So what Matt said is that he thinks that floresiensis is retaining the primitive morphology that we see in early fossil hominins from Africa, and this is very, very much like you would see at the node that relates African apes to hominins. So these are primitive hands. But boy, they were good enough to make these kinds of tools. They were good enough to, these are Pygmy Stegadon bones with cut marks on them. They were good enough to take flakes off cores and slice flesh off bones, mostly little juvenile elephant things called Stegadon. So again, small brains, perhaps reorganized, primitive hands, but substantial capabilities in the realm of tool behavior. All right, just a couple more. This is one that just really amazed me. When this was first described, it was another feature. This is the pelvis of LB1. And they said it looked like an Australopithecus, and I said. So I went and I tried to figure out a way to orient it. And I had no idea. It's really hard to do that. So some Spanish colleagues, Arzuaga, suggested, take Lucy's sacrum next time you go. See what happens. Well, here's what happens. It's a remarkable fit. Lucy's sacrum allows you to orient the pelvis of LB1. And what you see is this remarkable lateral flare. This bowl is created. And this is from Owen Lovejoy. Now, I love it when I agree with Owen about something. Here is Australopithecus, reconstructed by Owen. This is Lucy. The hallmark of an Australopithecine pelvis is a laterally flaring ilium. I got to tell you, these are peas in a pod. These are modern humans, and this is an ape. How can Homo floresiensis get away with such a primitive pelvis? It's all about obstetrics, right? A small-brained hominin has small-brain babies, and you don't need a large outlet to pass those babies, so you don't remodel the pelvis the way modern people do with big brains. And by the way, here's the Lerone individual seen on the left. It looks pretty modern to me. I don't, maybe it's just the orientation, but it doesn't look like an Australopithecus to me. Here's a Hobbit foot. No, not that one. There's a Hobbit foot. And I got to tell you, this is an amazing, amazing specimen. We have most of the foot. We don't have the heel bone, the calcaneus, but we can assemble for the first time a relatively complete foot that's got all of the tarsal bones except for the calcaneus. It's an interesting foot in many ways. It's a very, very mosaic foot. It's got a fully adducted big toe, but this big toe is short, and I'll show you some data to support that in a second. The whole tarsus is really squashed compared to this part of the foot. Very unlike humans. This part of the foot suggests that it had no medial arch like you and me, or some of us, and it was weight-bearing, not unlike afarensis and chimpanzees. But on the other side of the foot, we can see a little wedge, a little flange. It's a locking mechanism during supports phase. So it's a mixture of things. It's really, really quite remarkable. And here it is relative to the tibia and femur. Now, I don't know about you, but that looks like a pretty big foot to me. Imagine a foot that's almost as long as your shin. It's not quite as long as your femur, but you're going to look funny no matter what kind of shoes you wear. Again, you can sort of see the short, big toe, the probable weight-bearing part of this bone. This is a remarkable foot. But we can do a little better. We can get the full length of it. We can take a lot of feet at Stony Brook, and we can measure what's remaining of floresiensis and predict the full foot length. So here's that regression to show you we didn't make it up. And we come out with a foot in this ballpark, about 191 millimeters. And now it becomes obvious why the foot looks so big. It's because the femur is so short, the tibia is so short. The foot to femur ratio, literally the length of your foot relative to your thigh, these are in tall people from Cleveland. These are short people from around the world, pygmies among them. This is LB1. The foot to femur ratio in LB1 is like a pygmy chimpanzee. And that's because the femur is so short, the tibia is so short. That's why you have that funny humeral frontal index. That's why you have such short stature. This is an odd foot. And this is just some data to show you that the big toe relative to the other toe bones is right in here with chimpanzees. That's a short, robust, fully adducted big toe, but it's very, very short. What does that mean? It has several implications for how this guy moved. Foot length needs to be taken into account. Herman Ponser pointed this out, a former graduate student here, that you need to take foot length into account to get something called effective limb length. You need to project down below the ground. This is the true effective femur length. But even doing that, the foot length does increase a little bit with a big foot in the hobbits, but it still comes up short, very short. And that impacts the cost of transport and the energetics of bipedalism. Again, work that Ponser did here in these labs. They're improved a little bit by having a long foot, but they unfortunately don't compensate. And they also, the short hind limb and the extremely long foot probably places limits on the speed of bipedal running. And you probably see this thing, it would look funny when it walked, because your toes have got to clear the floor. So you have to lift your feet up higher. So if you go back to that story, the ratio of foot to stature is never observed in humans, as is the femur, but it's short only because of that. If you normalize it to upper arm, it's perfectly normal. Also been CAT scanning, because one of the claims that were made was that these bones are too thin, they're pathological. They're too thin and they're too asymmetrical. Well, here's a femur, both sides. We found high-resolution CT scanners in Jakarta. We scanned the bones, and here's what you see. All right, we're trying to. We've lost the little arrows that take you to them, but in fact, they're incredibly symmetrical. And not only very symmetrical, they're perfectly normal in their thickness. And this is just a plot to show you that. The percentage of bone in cross-section of the humerus versus the femur. Here's modern humans. They fit right in there, and they're just like Lucy in that respect. But what's even more amazing is when you take into account the cortical bone in cross-section, the body mass, and the length of the femur, LB1, like Lucy, has an incredibly strong femur. This is resistant to bending. This is a paper from Chris Ruth's paper in American Scientist. Through time, people get more and more gracile, and we lose that. Lucy's off the charts. Well, at 18,000 years ago, LB1 was off the charts too. So these bones are not thin. In fact, if they're anything, they're mechanically stronger than anybody's femur in this room. So, Now, I'm talking about the fossils here, all right? I want to get back to what Henry G. said, because I think it's really relevant here. This cognitive dissonance is a real thing, and it's happened before. It's not unique to hobbits, not even close. Richard Lydecker dismissed the type specimen of Homo erectus, the Trennel skull cap, that was found by Dubois in 1891, and called it a microcephalic idiot. Where have I heard that before? Jerome Dobson, as late as 1998, said that distinctive Neanderthal skeletal traits are identical to those of modern humans who suffer from cretinism. Deja vu. I just heard this last week about LB1. However, I think it's not just the pathology du jour. I think maybe I'm sensitive to this because I went to Michigan. But there is a school of thought who can't conceive, let alone allow, more than one species of our genus to have existed at one time, or maybe forever. They connect the dots back to euglena, all right? Therefore, if it can't be possible, then it must be pathological. And I really think that that's what we're faced with here. And just to show you, here's what some of these unfortunate individuals look like. This is LB1. This is a little man, a little Swiss man in a collection that had suffered from hypothyroidism his whole life. He's got normal limb proportions, but he's got terrible dysplasias in all his joints, a very narrow pelvis, internally rotated femur, normal size of brain though. That doesn't look like the Hobbit to me. Maybe I'm just blinded, but I just don't see it. And I would say the same thing for Laronne syndrome. This was published in Science. This is the individuals who suffer from MOPD2, this primordial dwarfism. Here are their foreheads. They have very gracile chins. They have short hands and feet. They have very thin bones. They have dysplasias of all kinds. And none of them have a carpus that look like a chimpanzee or an Australopithecus. You know, the suggestion at the end of this paper that this syndrome could somehow account for Homo floresiensis is just, it's stunning. That it must have been added in proof or something, because I can't imagine that it got to the reviewers. It's absolutely incredible. The phenotype of these individuals bears no resemblance to Homo floresiensis except for short stature. Okay, get off the rant here. I'm sorry. I'm going to skip this. I'm just going to. There's some other issues here about asymmetries. This is really very much smoke and mirrors. If you do a proper analysis, I can show you that the asymmetries in the skeleton and the facial skeleton are absolutely normal. So let me just wrap this up. What I'm going to suggest is that the skull, jaw, and postcranial remains of Homo floresiensis are remarkably primitive. That especially in the postcranial, they're also pith-like. And in some respects, they're early Homo. But hopefully, maybe, Homo habilis remains to be seen. These features, including small body size, appear, at least to us, to reflect ancestral retentions and must imply a very early out-of-Africa episode. Alternatively, this new hominid has dwarfed this from Homo erectus and re-evolved primitive characteristics. And that's an explanation very hard to explain in adaptive terms. Why do you give up a big brain? Why do you give up long hind limbs? Why do you give up a wrist and a foot that's modern in aspect? I just don't see it. And finally, there is no known pathology that recapitulates the course of human evolution. There isn't one. It would be fascinating to find it, but it doesn't exist. Thanks.